My name is Jordan. I'm here at the Old 100 Mine in Silverton, Colorado, almost 2 miles above sea level, and this is the chemistry question. We know alkanes as chains of carbon and hydrogen that contain only single bonds. Did you know alkanes can form rings? These ring structures form with 2 fewer hydrogen atoms than normal alkane chains, and are thus considered unsaturated. Welcome to the cycloalkanes. Cyclopropane is the smallest cycloalkane, consisting of 3 carbon atoms and 6 hydrogen. 3 points determine a plane, so the carbon atoms form a perfect planar equilateral triangle with 60-degree bond angles between the carbons. When carbon makes 4 single bonds, it typically forms a tetrahedral geometry with 109.5-degree angles, which allows for the bonds to be as far apart as possible. The carbon-carbon bonds in cyclopropane measure 49.5 degrees less than ideal. This gives the molecule quite a bit more energy and is thus less stable. Furthermore, the hydrogens are eclipsed, meaning they line up, and this gives the molecule even more energy. Cyclobutane is a roughly square-shaped 4-carbon molecule. Though 90 degrees would be the greatest possible angle between the carbons, the actual bond angle is about 88 degrees, even though this gives it more energy. Why? This allows the hydrogens to not be entirely eclipsed, and this reduces slightly more energy than is added from the additional bond angle strain. Cyclopentane follows, and is much more common in nature than the previous 2 compounds. If planar, the carbon-carbon angles would be 108 degrees, very close to the ideal of 109.5. Cyclopentane, however, has 4 planar carbon atoms, and the 5th rises slightly, giving a little flap. Once again, this is to reduce strain from eclipsing hydrogens. Now we get to cyclohexane, the most stable and common of the cycloalkanes. Bond angles would be 120 degrees if it was planar, but the molecule is not. Instead, it has 2 flaps, and in its most stable form looks like a chair with 1 flap going up and the other down. In this form, all bond angles are 109.5 degrees, which makes perfect tetrahedral geometry. The other conformation, known as the boat conformation, gives eclipsed hydrocarbons, and the electron clouds of the 2 flagpole hydrogens start to interact, giving static strain. Therefore, we usually only see the boat as an intermediate between chair conformation. Larger cyclic compounds are possible and fairly common, but they can get much more complicated, folding in on themselves. They are a topic for another time, but now you know about the 4 simplest cycloalkanes.